Hello out there to you. In this video, we've got a practice question having to do with elasticity, and we're going to calculate the elasticity of demand using the midpoint method. Now, a lot of these videos, I think you should treat them as practice. So if you want to practice your method, solve for elasticity of demand, and then watch me do it, see if you made a mistake or just verify that you did it correctly. That's a great idea. If you want to do that, pause the video and then hit play or skip to the end and watch the end of it. But anyway, okay, so the midpoint method sometimes sounds confusing, but it isn't. The reason we use that is so that it doesn't matter whether we're going up or down the demand curve. So price elasticity of demand, the formula is price elasticity of demand. Usually we're going to say this in absolute terms, but it is the percent change in quantity demanded over the percent change in price. And a lot of you have seen that there's a formula that sort of writes this out a little bit longer. Now, let's do that. Okay, so using the midpoint method, it's the same thing. So if you know percent change, you can use that. No big deal. Okay, so the change in quantity, so we could say quantity 1 minus quantity 2, so the difference between those two, over quantity 1 plus quantity 2 divided by 2. We're averaging that. Let me get that a little bit more room there. So we're averaging the quantities, quantity 1 plus quantity 2. Now, in a lot of these problems, you can just look at it and eyeball it and say it's halfway between the two. And then this is a percent, so we're going to multiply that by 100 if we want to be really technical, because price elasticity of demand is a ratio of percents, and that's why it's not the slope as you might want to say it is. Okay, so then on the denominator of the whole thing, we've got price 1 minus price 2, and then over price 1 plus price 2 divided by 2. Okay, the midpoint between that. This is also 100, and so you'll get the percent change in quantity over the percent change in price. Okay, so let's plug in what we have here. So the price is going from $8 to $12. I like to do the quantities first. So we'll do the quantity first over here. And we're dealing with this scenario here. So we're going from 8 to 12. So 12 would be the new quantity minus the old. So it's new minus old over old. Okay, now 12 plus, so we can do this in our head. 12 plus, I guess I should write it all out. 12 plus 18 over 2, but I can do that in my head. That's 15. Okay, and then times 100 because that's a percent. And down here, we've got the two prices. So the new price is 12 minus 8, going from here to here, over 12 plus 8 divided by 2 times 100. Okay, so we'll pull out our calculator. We'll say, even though I know what the answer is, it's good to do this. So it's 12 minus 18, which is -6. -6 over 15. It's 0.4. 0.4 times 100. So that is a negative 40%. Okay, that's the percent change in quantity. And then the percent change in price is 12 minus 8, which is 4. We can do that in our head. Divided by, well, it's 10. So it's 20 divided by 2, which is 10, which is also 40%. So your answer is either -1, price elasticity of demand, which means unit elastic, or often price elasticity of demand is just stated as a number in absolute terms. So then it would be a little bit clearer. That would be -1 in absolutes, which is the same way as saying 1. Also unit elastic. So your answer here is unit elastic, and that is how to solve price elasticity of demand using the midpoint method.